Welcome to Chem-1A at Shasta College. This is a short screencast on the rest of the material from the Wednesday, August 19th lecture that we didn't get to during class. First of all, which would you say is heavier, aluminum or lead? Well, if you held out your hand and I put a piece of aluminum in one hand and a piece of aluminum in the other, I think you'd very quickly decide that the piece of lead was heavier. But what if it was like that? Well, if they're equal-sized pieces of aluminum and lead, then the lead would be heavier. But it would be fairly easy to put a large piece of aluminum in one hand and a small piece of aluminum in the other, and then the aluminum would be heavier. So, kind of important to note that that's actually not a very good question, which is heavier, aluminum or lead. It would be much better to ask the question, which is more dense, aluminum or lead? And this is an important physical quantity known as density, and we use this a lot. It's the ratio of an object's mass to its volume. So it's a measure of kind of how compact the matter is in a sense, how much mass there is in a given amount of volume. And the density's mathematical relationship is density D is equal to mass M over volume V. And some of you may have already hit a question like this in the homework. It's covered in the chapter, but let's do an example. Suppose we have a piece of rebar and we weigh it and determine its mass is 69.658 grams. And then we get a graduated cylinder, put some water in it, measure the initial volume of the water. In this case, let's say it's 13.5 milliliters. Then we submerge the piece of rebar in the water in the graduated cylinder. Water is displaced, the volume of water goes up, or the volume of water in the graduated cylinder rises, level rises, and then we get a final volume of 22.4 milliliters, which is going to be the volume of the original water plus the volume of the rebar. And therefore, by difference, 22.4 minus 13.5 gives us 8.9 milliliters for the volume of the rebar. And then if we had a question like this one, with that data, and we were asked to find the density of the rebar, it's pretty much plug and chug into the formula. Density equals mass over volume. The mass and volume values that we got are shown, 69.658 grams divided by 8.9 milliliters. When we divide that out in your calculator, you'll get a number, or from your calculator, you'll get a number something like 7.82674, or maybe more digits. The units are grams per milliliter. And then, of course, we are taking a 5 significant figure number, dividing it by a 2 significant figure number. In the case of the graduated cylinder, we could estimate to the 10th place, and when we subtract, that gives us a 2 significant figure number, which means that our result has to be rounded off to the least precise of our individual measurements, which is the 2 significant figure number for the volume. So we have to report our density as 7.8 grams per milliliter. And then this might be a way to identify a metal by its density, or at least tentatively identify it by comparing your measured and calculated density with a known value. Now, it's worth noting in this class, the level of math that you're going to have to be able to do, definitely got to be able to do some basic algebra. So you should be able to fairly quickly and easily and correctly do these sorts of things, which are fairly straightforward, plug into an equation. But of course, you should also be able to, let's say, knowing the mass and the density, figure out the volume, or any other kind of permutation of these sorts of algebraic equations, solve for an unknown. Okay, here's another thing. This is just sort of descriptive stuff, but mass is what we call an extensive property, because if we have a small object, let's say a piece of aluminum, then it's going to have a small mass. If we have a much larger piece of aluminum, it's going to have a larger mass. and extensive properties are ones that depend on the amount of material we're talking about. So mass is extensive because the more stuff, the larger the mass. However, density is what's called an intensive property because, again, let's say we're talking about aluminum, the density of this small piece of aluminum and the density of this large piece of aluminum are the same. Both have the same ratio of mass to volume, and that's what an intensive property is. It doesn't change its value even if the amount of substance changes. So here was a learning catalytics question that we did in class. Not super successful on the results, so let's kind of go through this one fairly quickly. Determine whether each of the quantities below is extensive or intensive. And mass, well, we just did that one. It's extensive. More object or more stuff, larger mass value, therefore extensive. Volume, same thing. If we have more aluminum, it has a larger volume, so that's an extensive property. Density, well, we just did that one. That is intensive. The density of the aluminum doesn't change if we're looking at a lot of aluminum or a little bit of aluminum. And then what would you think for temperature? And again, if we're talking about, let's say, a piece of aluminum, the temperature of that piece of aluminum is going to be the same whether we are looking at a little of the aluminum or a lot of the aluminum. And of course, we're talking about in sort of the same situation. Okay, now the other thing that we did in class and didn't finish all the examples is use of conversion factors, or what's often called dimensional analysis. And note that this is a very powerful, very useful way to solve problems. It can solve practical problems. We'll do a couple examples. And worth noting, you can often use conversion factors and dimensional analysis to get a correct answer, even if there's an equation that's appropriate and you don't happen to know the equation. So it would be very good to practice this. There's an activity that has many of these types of problems that you may be working on in discussion or outside of class. And then, of course, there's some conversion factor dimensional analysis problems in the homework. So, get good at this, do some practice, and then, of course, pay attention to your setup, show units, get your sig figs right, etc. It'll help you a lot in the course, especially when we get to reactions and mole calculations. Okay, so question 8. You can read the question, dealing with a drug used to treat asthma, and we need the dose for a particular situation. So how we do this is, note we have two values. We have a 175 pound person, so body mass of 175 pounds, and then we have another number, 6 milligrams of elixophyllin per kilogram of body mass. And generally speaking, if you have more than one value given in a problem, or if you look up some values, it's generally good to start with a single value rather than something like the 6 milligrams per kilogram, which is, it's a value, but it's actually a conversion factor. It's a ratio of two values. So start with 175 pounds of body mass, find a conversion factor that converts from pounds of body mass to kilograms of body mass in this case, and it's 1 kilogram is 2.205 pounds, a value that you look up if you don't happen to know, and that converts the person's mass from pounds into kilograms. And then we look for a factor to convert from kilograms of body mass into, in this case we only have one more step, into the milligrams of the drug elixophyllin. So 1 kilogram of body mass requires 6 milligrams of elixophyllin, and we get our units to cancel. And then we multiply 175 by 6 milligrams, divide by 2.205. You can do those in whatever order you want. And you should get a number something like 476 milligrams of elixophyllin. And then note, 3 sig fig number, 4 sig figs, and then the one has, as many sig figs, or 1.00 more sig figs than you need. But then here, the 6 milligrams of elixophyllin per kilogram, that's a 1 sig fig number. So you really need to report the value to one significant figure. And if you write 500, it's a little ambiguous, but if you write it as 5 times 10 to the second milligrams of Elixophyllin, it's pretty clear. We have little Lenny with some lead in his blood. We know the concentration of lead in his blood, but we'd like to know how much actual lead there is, like how many grams. And note that in this problem, we're not going to get very far unless we also know Lenny's blood volume. And on average, people have a blood volume of something in the range of maybe 5 liters. Lenny's is a little less. His blood volume is 4.2 liters. And now you might want to think about where you'd start. And as before, note that we like to start with an actual amount, the 4.2 liters of blood, because the 34 and the 10 are both conversion factors that we'll end up using. So what we're going to need to do is convert from liters of blood into deciliters of blood. And the reason we're doing that is because we have a concentration in milligrams of lead per deciliter of blood. So we'll convert from liters to deciliters, and then we'll convert from deciliters of blood to micrograms of lead. So that funny little M-looking thing is actually a mu, stands for micrograms. So there's 34 micrograms of lead per 1 deciliter of his blood volume, and that cancels deciliters. And since the question asks us to find grams of lead, then we need to know how many micrograms there are in a gram. And it turns out, since a microgram is a millionth of a gram, there are 1,000,000, or 10 to the 6th, micrograms per 1 gram. So 10 to the 6th micrograms of lead per 1 gram of lead. And those units cancel. And then we do the appropriate calculation. And we end up with 0.014 grams of lead. And that's not a lot of total lead to be, that's all lead that's in Lenny's body, but that's way above the what's called action limit, which is essentially you have enough lead in your body that you should go and get some medical help. Okay, so that's it. That's all the stuff that we didn't cover on the handout during class on Wednesday, August 19th.